The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. It usually starts with 0 and 1, and for some reason, it's everywhere I look. You see, nature likes its constants, and the golden ratio happens to be one of them. I stumbled into the Fibonacci sequence while watching a video on seeds dispersal, and I thought, generating this should be easy, right? Oh, how wrong I was. I booted up my PC and opened up Godot. Why didn't you use Python? You might ask. Well, to be honest, you can run this code wherever you like. I chose Godot because I know basic GD scripts, and I also want to get better at game development. The first step for running this sequence is to define some variables. The first two variables are starting numbers 1 and starting number 2. Then we define a variable called count and maximum. Count tells us how many numbers we have generated, while maximum tells count how high it should go. Lastly, we'll create an array to store all our numbers. In this video, I'll be using a ready function, but feel free to create yours. The first lines in our function append our starting numbers 1 and 2 into the array. In this case, we're defining our starting numbers 1 and 2 as 0 and 1. Then we create a while statement. For statements are generally safer, but since this program is light, we should be fine. Every time our program runs, we're going to add 1 to our count, then define a new variable called sum to be equal to num1 plus num2. Then we make num1 equals to num2, and num2 equals to our sum. You end the function by asking it to print our list. If you did everything correctly, you should see that the values in our list follow the Fibonacci sequence. Here comes the hard part. How do you visually represent this? At first, I thought I just tell the computer to draw a box with an area equal to each element. However, all boxes ended up being in one plane. So how do you write a program that defines a starting position that's unique for each of our numbers? And as if that wasn't bad enough, we also have to tell Godot what direction each box should draw to. I mean, there are 4 quadrants, and each value points towards a unique one from the last. And to make all this worse, this is just for drawing boxes, not to talk of actually making the arc that binds the Fibonacci sequence together. I don't want it to repeat my mistakes, so I won't be sharing how I got to this terrible code. But I still recommend everyone that watches this video to try it out on their own, and let me know what you did in the comments below. See this as a challenge from nature to you, so one day humanity will be smarter than the pine cone. And as always, thank you for watching.